Welcome back to my video for making a 2D framework off on top of LibGdx. In this video we're going to create a motion class, and what a motion class is going to do for us, it's basically going to encapsulate all of these animations that build the character moving about the screen. So let's go ahead and get started. We're going to create a new package for our motions. And then we're going to create a motion interface. Now there's going to be similarities with the animation interface, the draw method, and the update method. This is our motion interface. It has a draw method, which takes the spring batch, the X and Y coordinates, and it has an update method that takes the delta time, and it also takes the direction that our sprite will be moving in. Okay, next we're going to create another class to help with our motion. We're going to actually create this into our movement package, and this class is going to be called direction. And so for our direction, we're going to set up static constants for our 16 cardinal directions, including a no direction, which will be set to -1. So our direction class has a static method for getting the direction based on an origin X and Y and an origin or a destination X and Y. And so it determines the distance between the two. And if they are the same, then there's no direction. And so it uses the Pythagorean theorem to determine the angle, and so it takes the adjacent destination X minus destination Y, and then the hypotenuse, the destination Y and the origin Y, and then uses a fast math class to get the antitangent and look it up by degrees and to get an angle. And if our hypotenuse is less than 0, we take our angle and we add 360 to it, so we have a positive number. This is the fast math class that I pulled from javagaming.org. These are some of the contributors of the various methods. Special thanks to them. It has pre-calculated fields, and some of those are antitangents and degrees, and calculating for kind of big enough ints, and so it has methods for calculating the antitangents, simplified method for getting absolute values, antitangent 2-degree lookups, and a whole bunch of classes, or a whole bunch of methods for quick calculations. Back in our direction class, we have another static method. This is for taking the degrees and converting it to the nearest fourth direction. So if the degree is greater than northeast and less than northwest, it converts that to a north. And if it's between northwest and southwest, it converts it to west. Southwest to southeast, converts it to south. Otherwise, it converts it to an east. And then there's this convenient method to convert to 360 degrees. That is actually what it does. If your degree is less than 0, it will add 360 to it, and it'll keep looping until it's between 360, 0 and 360. If it's greater than 360, it does the opposite. It subtracts. And so it returns a value that's between 0 and 360. The next static method is the nearest 8th direction. This takes the degree and then converts it into either northeast, north, northwest, west, southwest, south, southeast, or east. Now that we have our direction set up, let's go back into our motion. Now we have our interface here. What we're going to do is we're going to start by creating a single motion. And this is for when no matter what direction the sprite moves on the screen, it will always display a single animation. This is the implementation of the single motion. So it has a single animation, and so the constructor will just take that single animation. The draw method will draw just that single animation, and the update method just updates that single animation, not taking into account the direction that it is moving. Now we'll move to another motion, and this will be a two-way motion. This is the two-way motion, and so it has an animation array of two elements. It has a direction int, which is the index of those two elements. And then the two-way motion can be either horizontal or vertical based on this flag. This is the constructor. It'll take a direction 1 and direction 2. And if your vertical, direction 1 is up, direction 2 is down. If you're horizontal, direction 1 is to the right, and direction 2 is to the left. This is a draw method, and it does the animation, and based off of the index of the direction, determines which one it will draw, and it'll draw it on your X and Y location. There's a method to set it to be either horizontal or vertical. And this is our update method. And what it does, it will convert the direction to 0 to 360 degrees. And if it's horizontal and your direction is between north and south, your direction index will be 0. Otherwise, if your direction is vertical and you're between east and west, set your direction to 0. Otherwise, your direction will be, index will be 1, and then it will call the update method on that animation. So no matter what type of animation you're using, it will use the appropriate one for going either east and west or north and south. And the next class that we're going to create is a four-way motion. So in this class, it will go basically one of the four cardinal directions, north, south, east, or west. We'll create indexes, static indexes for north, south, east, and west. Here's the implementation of our four-way motion. And with our indexes, we add an animation that has 4 elements, and then we store the index. And our constructor will take the animation north, east, south, and west, and then set those into our animation array. This is our draw method. So it just draws the animation based on whatever the current index is. And this is our update method, which takes the direction as well. And it calls our direction nearest 4th direction to get the nearest 4th direction. And so if our direction is north, it'll set the index to north, and east, the index to east, and direction of south, the index to south, and the direction to west index. And then we call the animation based off of that index, and we run the update for that animation. Okay, I have copied over the code from the animation screen into our motion screen. And we'll now go in and implement our motion. So we have our four-way animations, down, left, right, and up. And so we will add in our motion here. We're going to do the four-way motion. Our four-way motion. Here's our animation. We'll create our four-way motion here. And we'll add in all of our directions. And so what we'll do is we'll change our direction from a char to a float. Okay, and I changed our switch statement to if logic based off of the direction. So if our direction is heading east, we'll update the x coordinates like we did before until we got to 200. Then we go to north. And if we're going north, we update the y coordinate. And we get to 200, we change it to west. When we're going to west, we subtract the x coordinate until we get to 100, then we go south. And then if we're not, the else block is for south, and we subtract the y coordinates until we get to 100, then we go east. We do our four-way motion. We call update, pass in the delta time and the direction. And then we do our four-way motion, and we do a draw with the batch and the X and Y location. And let's run that. And there we go. The character's moving to the right, north, west, south, and then east again. Now I'm going to demonstrate the single motion. I create my single motion. So I'm going to take this texture region and create a magic egg, which is 39 by 48. And we'll use loop animation here. Then I'll create my single motion, which just takes that loop animation. And what I'm going to do is down here, I'm going to use my single motion, do my update in the direction instead of the four-way motion. Single motion, then I'll do it my draw method. And so now that's a single motion, and so even though I'm passing in the direction, it's not going to change the animation based off of the direction. So here it's going. Even though it's making the circle, it's still the same animation. So I removed all the animations as class variables. Since they're being put into our motion object, so we only have the motions as our class variables. Now I've added a two-way motion. I'll demonstrate that. So I have a character called Jojo running, and it's two animation sequences, one going to the right, one to the left. And so I've create the animations, and then I have my two-way motion, and then we have him going in the east direction until he gets to 300, then he goes west until he gets to 100, and then he goes back to east. And then we do update, and then we do a draw. And so here he is running to the east, and now he's running back to the west. So the next motion that we're going to cover is the 8-way motion, and I pre-coded that, so I'll just walk right through it. So we have an index for all of our 8 directions: north, northeast, east, southeast, south, southwest, west, and northwest. Our animation array has 8 elements, and then we have our index again. We have a method that takes all 8 values and stores them. Our draw method just does the animation index draw. Our update method will take the direction that's passed in, call the nearest 8th direction, gets that, and then does a for loop based off of the direction, and if it's north, northeast, east, and all the directions, and then once we get through the loop, we do our animation and our index, and we do update on the delta time. And one thing that we can do to improve this even better, since two-way motion, usually we're going to use a loop animation. Here in our two-way motion, we created a constructor that takes the texture, the tile width, the tile height, and the duration. And this method will create our texture region and our loop animation, so we don't even have to worry about building that out. This does it for us. And this assumes that your first element in your texture region is for 0, going in your up or your right direction, and the second one, element 1, is for going in the opposite direction. And then if your animation sequence is different, this method will take your texture, tile height and width, and the duration, and then you can specify which element is for direction 0 and direction 1, and then it will create it accordingly. So then we'll update our motion screen to use that. So we have our constructor here now. Now we're taking just the texture region, the size, and the frame duration. And then when we run that, we got him, he's going backwards. just use our other constructor. And there he's going forward. And that's how that works. And we can update our 4-way and 8-way motion similarly. So now I updated the 4-way motion, and so it takes the texture, the tile height and width, the duration of the frames, and then the elements that for each direction. And we'll run that. And there she is going to the right, going up, and then back again. And so now to create our animation sequence to go in 4 directions is a single line, as opposed to the loop animations being created, the 4-way motions being created, even when we did it here, where we had each individual motion, each individual animations, and then we had to update each one individually. It's much more simplified now. That is our motion class. Now I'm going to go back to the animation class, and we're going to implement setting the colors like we discussed in our second video. So I've added to the interface setting the color based on the LibGdx color, a red, green, blue float, and then the red, green, blue int, which is an integer between 0 and 255. I've also added set size to our animation interface. And so these are now implemented in our base animation class. So we have a protected field of color, and then our set methods. And then in our draw method, if you remember from that second video, you have to set the color on the batch and then draw your image, and then you need to set that color back to white. And so we do a check here to verify that the color is actually set before we actually set it. And to make this work with the child classes of this one, we've added a draw child method, and so that gets called. And these draw child methods are simply the existing draw method, but the method name is changed. And here in the loop animation is an example of the draw child method. So it's the same code that it was before, it's just now in a different method. I will demonstrate how that works. So here we have our magic egg, and this is the loop animation 1. And what we'll do is you'll set the color, and we'll just set that to blue for right now. And there we have our egg. It is now blue in color. Now I'm going to change that color to gold. And there it's gold. Now you can't really tell since that ring is blue, but you can see it's not as solid as a blue as before. And that ring is also being changed to color, kind of a yellow hue to it. And so what we can do is we can create another animation class that will split out the egg and the ring. So we'll go back to our animation package, create our new class, and this is going to be a layered animation. And what this layer animation will do is have layers of animation that it will render. So here is our layered animation. So it's extending the base animation. It has a list of animations, so that can be dynamically added any number of layers. The constructor takes a single animation and sets it as the first element. And we have another method for adding additional animations. So this can be called multiple times, and then adds them. And then we have a convenient method for getting a animation at a particular index. And here's our update method. So it loops through the animations and then just calls the update method for each animation. And then our draw child method also loops through each animation, and it will call the draw method for each of those animations, starting with the first one and then going to the second one and the third one. So the first one is your bottom layer, and your second one that you add will be on top of that. So go back in our motion screen and we're going to create a animation for our egg, which is a static animation. And instead of the magic egg here, we're going to use the magic ring, and it's the same size as the animation egg. And so here we'll create the loop animation as we did before. And then here we'll set our egg color. So we'll give it a nice Easter egg looking chartreuse. Then we'll create our layered animation. New layered animation, and we'll start with the egg at the bottom. And our layered animation, we'll add an animation for our loop animation 1. Then on our single motion, instead of passing in the loop animation, we're going to pass in the layered animation. And then we'll render that. And there's the egg is now that green color. And the ring doesn't have a hue to it, so it looks pure blue, like it was originally created. And that's how the layered animation works, and you can do any number of layers. And if you like this video, just click on the like below and feel free to subscribe for more videos on building this 2D framework that you can use in your own game programming. Till next time.